Good morning, good afternoon, people. I hope you're making use of the time that you're allowed to go outside and enjoy the fine weather and get a bit of fresh air, vitamin E or D, whichever one it is, the one that comes from the sun. That's for you to check and investigate. Right, so we're going to move on today with this geometry chapter, and we are going to look at angles in polygons, and I think I am going to split this into two sessions possibly. So first of all, you need to be able to define what a polygon is. We've done this before, but if you cannot remember, a polygon is a 2D shape with three or more sides where all the sides are straight lines. Okay, so a semicircle is not a polygon, and that's it basically. So three or more sides, all sides straight. That's it. That's a polygon to the shape. Right. Now I don't know. It's a pentagon. You all know that. The other thing that you need to remember, or you need to learn, is to differentiate between a regular polygon and an irregular polygon. So you're going to have to take notes here. If I have a regular polygon, well, that means that all the sides of the polygon are the same length and all the angles are equal. So what's the name for a regular triangle? Equilateral. The name is equilateral. Okay, what's the name of a regular quadrilateral? What we call that square. And then we have a regular pentagon, regular hexagon, regular heptagon, blah blah blah. And if it just so happens that not all the sides and all the angles are equal, what I have is an irregular polygon. It could be an irregular pentagon, it could be an irregular quadrilateral, it could be an irregular triangle. So an isosceles triangle would be irregular because not all the sides, not all the angles are the same. Right. Right, so then just moving on to polygons. There are, in a polygon we have interior and exterior angles. So I assume, I guess, typically here I would get someone to come to the board and ask them to show us an interior angle. Now you don't have to be very clever to figure this one out because the interior angles are inside the polygon. So in this case of the pentagon, I have 1, 2, 3, 4, and 5 interior angles. So all these angles here are interior because they are inside the polygon. Who would have thought, right? Okay, then this one I will have a bit of fun. And I would ask someone to come and show me an exterior angle, and who thinks they can show me an exterior angle, and you will all get really excited. And then just for fun, I will get Ugo or Jordi to come and get it wrong, because typically 99% of the time people get it wrong. So if you think you got this right, just wait for the big reveal, because you're probably wrong. So I will ask people to come and show me an exterior angle, and then typically Ugo or Jordi, but possibly Mark maybe as well, or I don't know, let's pick on some of the girls. I don't know, not Carla. Carla would be too scared to come to the board, but Clara might, you know. So I will ask them to come and show me an exterior angle, and typically what people do is this: they go there, and that's wrong. That's not an exterior angle. What? But whatever. That's not an exterior angle. This here is a reflex angle. So a reflex angle is an angle that is more than 180 degrees. So that's a reflex angle. That's not an exterior angle. So now you're wondering, now you're thinking, okay, what is an exterior angle? Well, let me show you. The exterior angle is the one that tells me how much I need to turn to get back into the shape. Let me show you with an example. Let's say that I am traveling along this side on the pentagon, so I'm traveling in this direction. So when I get to the end, if I extend the side, how much do I need to turn to get back onto the pentagon? So this angle here, that angle there, that one is the exterior angle. And if I got 5 interior angles, I must have 5 exterior angles. The other one, so if I'm traveling along this side and I extend the side, this one there, and if I'm traveling along this side and I extend the side, this one here would be an exterior angle. And if I'm traveling along this side and I extend it, that one there is the exterior angle. And then finally, if I'm traveling along this side and I extend the side, that one there is an exterior angle. Looking at the diagram, there is something that you should be able to figure out or conclude or tell me about interior and exterior angles. What's the relationship between an interior and its exterior angle? What can you tell me? Look at it. What do you think happens? Interior, exterior angle. They are on a straight line. So the interior and the exterior angle are on a straight line. So they must add up to 180 degrees. So the interior plus the exterior angle must equal 180 degrees. That is something else that you should learn and be familiar with. One more thing possibly that I want to show you about exterior angles, but I'm going to try to show with an animation. I'll show you something there, so let's go. Okay, so this is what I wanted to show you. Forget about the blurb there, forget about the words, just look at the picture. Here I have my pentagon and I have the 1, 2, 3, 4, 5 exterior angles. Now, what do all those exterior angles add up to? Because if I have a regular polygon where every interior angle is the same, you know the interior and the exterior angle must add up to 180 degrees, so all the exterior angles must be equal. And look at what happens here. If I collapse the pentagon, look at what's happened. All those exterior angles go around a point. And what do we know about the angles around a point? Well, they add up to 360 degrees. So we can conclude that all exterior angles in a regular polygon add up to 360 degrees. There you go. And you can go into my iMaths and have a play with it and see how, you see, we're animated. Yeah, it's fantastic. We can do exactly the same thing here with a hexagon. I've got a regular hexagon, so all the interior angles must be the same, so all the exterior angles must be equal. And if I shrink that hexagon, you can see that all 6 exterior angles go round a point, so they must add up to 360 degrees. So if all 6 angles add up to 360 degrees, how big is each one? I'll leave that for you to figure out. And here I've got a nonagon, a 9-sided shape. And again, if you pay close attention, look at how exciting this is. And if I collapse the nonagon, all 9 exterior angles go round a point. So all 9 exterior angles must add up to 360 degrees. So if all 9 angles must add up to 360 degrees, how big is one exterior angle? That's for you to figure out. And if I know one exterior angle, can I find one interior angle? Ooh. And if I know one interior angle in a regular nonagon, can I find what all the interior angles add up together? Have a think.